Greetings, I'm Peter Denning. I've been hosting the Harnessing AI series for you the past 21 lectures, and we're here today to give you a final summary of what we talked about. This is my summary of what I think we talked about. Obviously everybody's probably got their own summary, but I hope this will be helpful to everybody in understanding the coverage of what we did. So we had several objectives that we covered in this course. One was to talk about the dimensions of AI. So when we talk about AI as a field, as a subject, what is included? So that's what we mean by the dimensions. So the things we specifically talked about are a machine learning hierarchy. This was about the first third of the course. We talked about different kinds of machines and how they go about learning. So these included the neural networks, the supervised learning, the unsupervised learning, reinforcement learning, human-machine teaming, and aspirational AI. So we had people talking about the specific kinds of machines that have been designed and existed in each of those categories. Then we switched to talk about implementation of AI in selected key domains of interest to us. So we talked about robotics and vision, natural language processing, and a number of other areas where AI has been applied. Mainly to give you a view of what kind of things people have been doing in these areas and what's been accomplished and what kind of things they're still working on. Then the final segment of the course deals with a bunch of issues around strategy and risk. So why are we nationally so interested in AI? What are the other countries doing? What is our government doing? What is our private industry doing? And what kind of risks do we have to face up to as we move along? We've also, as we've gone along, emphasized strengths and limitations of artificial intelligence. So there's some things we've seen the machine learning is very good at, and there's other things we've seen it's either not good at, or at least we don't know how to do it yet. And we need to keep all of these things in mind as we try and use these systems. We've also stressed issues of reliability and responsible use. So these new systems, we still don't completely understand where they're reliable, and we have to continue to try and understand that. We also have to make sure that when we put them into use, we're doing so in a responsible way. And we've set up ethical frameworks to help us think about that. We've also talked, especially in the defense concept, about the new face of battle, especially the lecture that was given by John Arquilla on this topic. The existence of so much large-scale AI and automation is changing the way militaries think about war and carrying out conflicts. And a lot of the technologies that have been built for past conflicts are not helpful in the future conflicts we're worried about. So all of this AI is figuring into that and is changing the way we have to think about war and battle. So John Arquilla has invited us to do that. And the final thing we've been emphasizing is seeing through the hype. There's been an awful lot of hyperbole around what AI can do. It can solve almost every problem on the face of the earth, you'd think, if you listen to all of the news, and that's simply not the case. And our speakers have emphasized where we can use AI and where we can't. But this is an important thing. Anybody who's trying to grapple with this field is going to be subjected to a barrage of hype. We just can't seem to avoid it with this field. I want to focus on this hype thing for a little bit, because it's been one of the key ideas is defeating hype in this course. So here are some examples that you hear about all the time, and I'm just going to quickly run through them. First one is a general claim that machines are intelligent. The second one is that with AI we achieve dramatic breakthroughs in all applications. The third one is that programming is dead. We don't have to learn programming. Long live machine learning. Machines are going to figure out how to program themselves. Another one is big data is the most important aspect of AI, so everything depends on the data. And another one is AI confers unbeatable geopolitical advantage. And even though we sometimes worry about some bad things, some harms that could come out of AI, the good so far outweighs the harm that we should just continually proceed. Let me take a look at some of these statements here very quickly and pull things out of what the speakers have said on these different topics as we've gone along. So we've seen this set of different kinds of machine learning here, rule-based logic, supervised learning such as neural networks, unsupervised learning, machine-human teaming, and aspirational machines. So these, almost all the work that we've reported on where there's been progress has been happening in the first 4 categories on this list. So these are the machine learning categories. So these are the categories in which we use these different types of machines to automate things. And there's no intelligence required because we already know what we want to automate. And so we've devised certain different types of machines to go about learning from their environment, from the data, what function they should be carrying out. And then aspirational machines are the machines that we dream about or worry about in some way, but they're not here. And in many cases, we don't even know whether they're ever going to arrive. So we call them aspirational. And maybe there's machine intelligence involved there, but it's in the far future and yet unknown. So the lesson from all of this is to just be careful of a lot of the progress that's been made in artificial intelligence is with machine learning. And a lot of the risks are with machine learning, and very little of it has to do with machine intelligence. We so far have not devised intelligent machines. Well, we've also seen this one, dramatic breakthroughs in applications such as data science, management, vision, cybersecurity, natural language robotics, and ethics. So most of the power of these advances is coming from the computing power that we now have able to apply to this. So we're able to look at much larger data sets, and we're able to have much larger networks collecting data for us and doing sensing. And we have stronger and better algorithms that we can apply, and we have compute power to do all this. So computing power is maybe the more dramatic reason than intelligent software in these things. And also just the scale of the networks that we have for interconnecting us, interconnecting our sensors, and gathering data. Some of the techniques that are being used in these areas were previously too expensive to use and are now within the reach of the computing power that is available. Here's another one you hear a lot about. It says, we no longer have to program anything because the machines are going to self-learn and self-train. Long live machine learning. Well, this is also one of these, I call them fraught issues, because if you take a look at some of the things that were described to you by some of the lecturers, like the robotics is a good example, is implementing AI involves a lot of programming, and it also involves a lot of different types of subsystems that have to be put together, and the AI is one component of a larger system. So when we implement AI, we still wind up designing and programming algorithms. They may not be specifically in the pure AI component, but they're somewhere there. We've got to program other pieces of the system. And also, teaching from numerous examples, this applies to a subset of the system and not to the whole system. Reinforcement simulation is another one that we use, is where we do lots of simulations. And for example, in the machines that learned how to play chess and Go, we took two machines and had them play each other until they finally learned from each other how to play chess. That's called reinforcement simulation. But these are very specialized cases. So they get a lot of news headlines because they're kind of new and glitzy. But the real work of implementing AI to be operational involves all of these kind of things plus more. So good engineering, which is what we want with useful applications, requires all three of these things. Designing programming algorithms, using the AI that we have in the components where it makes sense, and then putting everything together into a reliable system. That's engineering, and it's much bigger than simply the components that do the artificial intelligence. Big data is the most important aspect of AI is another hype statement. If you actually listen to the lectures, they say the data are important, and we all agree with that, but there's a lot of problems with issues in the data itself and also with the way the machines respond to the data. So there's synergy between big data and neural networks. Obviously no contest on that one because we need these large training sets to teach the neural network what its function is going to be. But neural networks are a small part of machine learning, and they're also a small part of actual working systems. So neural networks require huge training sets, as you've seen. When we're dealing with neural networks that try and recognize issues coming from images, you frequently hear people talking about 100 million labeled images. So, preparing radiology data and trying to figure out, if you look at a new image of a patient, whether, let's say it's a colonoscopy and you're looking for polyps, these systems had to be trained on like 100 million images of radiological data in order so that they could learn what a polyp looks like. Well, getting 100 million labeled images is very expensive. And theoretically, it's going to be 100 million images labeled by radiologists in our example, but this is very expensive. What radiologists are going to sit down and spend many, many weeks and months labeling images? So we wind up with cheap ways to label images, and we wind up therefore with dubious quality in the training sets. And the final issue here is that some of these AI systems do work well with large amounts of data, but you have to train them for weeks and months. And they use up huge amounts of energy in the process, and a lot of people just simply don't have the access to that kind of computing power and that kind of energy. So the practicalities of using large data are many and difficult, and it's better to say maybe we can't count on the data being everything we say it is. We've got to use our common sense better and not get sucked into the idea that data is everything. So a lot of AI is actually programmed. You look at some of the systems, the AI systems, you see multiple components in there. Maybe there's a neural network in there, maybe there's a machine learning somewhere, but there's also a lot of other somewhat more ordinary and traditional components, and they have to be programmed. So a lot of AI is actually programmed, it's not machine learning. And a lot of the uses of machine learning require little external data. The machines will generate a lot of internal data. For example, the machines that were learning how to beat each other in in the Go game, the AlphaGo machines, those machines use very little external data, but they generate a lot of internal data. So we got to be careful with this claim here about data. There's another one, AI confers unbeatable geopolitical advantages. So certainly there's some factors here that help make this, that support this statement, like speed. We can make decisions faster. We can get somehow situational awareness faster. We can explore alternatives faster. We have more computing power and more network power available to speed things up. There's a low cost of entry here, so almost anybody can get AI software and start trying to do things. There's ease, as we've seen, ease of misuse. There's difficulties in trying to regulate all this stuff. And there's a big growing problem with adversarial attacks. As you've seen, a lot of the speakers were concerned that if their systems were being deployed in operational situations, that there are various ways that adversaries could come along and try and defeat the system, or at least confuse it so that it becomes useless. So this claim about unbeatable geopolitical advantages has to be taken carefully here. So that is one of the reasons there's so many strategists involved in trying to understand how countries are going to interact with each other in a world that has a lot of artificial intelligence in it. Another piece of hype is this one, AI confers more good than evil, which is a way of trying to overlook the issues of harm that come up here. So we certainly don't need Skynet, all the bad scenarios from the Terminator movies to imagine bad things to happen. There's lots of bad things that happen even if you don't have intelligent networks around. So adversarial attacks are a big worry. We could wind up depending on AI systems to make important decisions, and then the adversary has ways of confusing the system, jamming signals that come to it, or confusing the sensor data input by jamming the sensors, and otherwise, contaminating the data and making the systems behave in ways that are not helpful or useful. So this is a big consideration, and there's a lot of people looking into it, but we don't have answers there. The third thing on this list is the slaughter bot scenario, which is the idea that we could build automatic systems or automatic swarms of small systems that can carry out large amount of destruction automatically. We just send 10,000 drones out and they'll destroy lots of things. So people imagining these kinds of scenarios and then trying to figure out how they might respond to them. So there's another way that AI is seen to potentially cause harm, and we don't have an answer for it. The last one on here I call artificial stupidity, which is just my take on some of this stuff about where AI is taking us, is that we are, as we've said many times, machines that we have so far can't think, they don't have compassion, they don't have empathy, they just follow their rules. And when you put a lot of machines together into a network, you get the possibility of the network doing some very stupid things, and it's all automatic and it's hard to turn it off. So we could wind up with more harm coming from this than from artificial intelligence. The stupidity of machines that aren't intelligence being applied at large scale but across a network. So I personally worry about that one a lot myself, in addition to other kinds of harm that AI can explicitly perform. So this piece of hype needs to be taken with a grain of salt. There's a very nice article that I think get your feet back on the ground with hype here, published in July a couple of years ago in the USNI proceedings by Commander Brent Spillner, who was talking about bedrock principles of artificial intelligence systems implementation. And these sound like pretty much things that we already know how to do with other software systems to try and make them reliable. So first one of his principles is that implementations in the field are engineered specifically for reliability, safety, and security. So when we put things into the field, we specifically worry about, are they reliable, safe, and secure, and design them so that they are. And we pay a lot of attention to that in the engineering. So we have to do this by framing realistic expectations, throw the hype out, ask what can this technology actually do and what can't it do, and be realistic about that. Always keep people in the loop because, as we know, machines are not intelligent. If you want some intelligent action, you need some human agency in there. We also want to keep the roles and limitations clear so that you don't have mission creep and pieces of the system doing things that they're not supposed to be doing. And finally, everything has to be designed and tested to standards that we can measure so that we can be sure that in the end we wind up with reliable, safe, and secure systems. Well, that is a summary of the, watch out for the hype, apply good engineering to the systems that we're going to deploy, and when we do all of that, that's all good, but there's still a few things that people are worried about yet that we don't know how to deal with. And these are called dilemmas. You've heard about them as we've been going along, but I've listed them out here. Big areas of concern. AI is going to have a big influence, but we don't know how it's going to turn out, and we worry about these things, and we're looking into them. So one of them is the geopolitical consequences. Another one has to do with arms control. Is in this area with automatic weapon systems and cyber attacks, is it possible to do arms control? That's a big question. The issues of fragility and intelligibility keep coming up. Fragility means that in the case of neural networks, a lot of these networks will work well on the training data, but they get unpredictable on new inputs which have not yet been trained. And when you ask them, how did you come to that conclusion, the only thing they can tell you can't make sense of, it's unintelligible. So this is a dilemma. How do we deal with that? Another dilemma is adversarial area. How do we deal with the questions where things might be disabled by adversaries? And going along with that is trust. How do we know when we can actually trust the AI system, even in critical situations? Bias is an issue. You've heard a lot about that one. Getting reliable data to make decisions with, to train the systems with, and even to figure out what to do in current situations. Getting reliable data is very costly, and so we wind up, maybe for cost reasons, taking shortcuts, and the data winds up being unreliable. Again, we don't know how to deal with that. Another one we've mentioned is deep fakes. It's now becoming possible with simulations and videos, recordings and everything, to produce what look like authentic recordings of events that are taking place and people acting in them, and it turns out they're all faked. And these can be used to influence political decisions and other things that are very troubling. So a lot of people are worried about the technology is coming to the point where we can make things that are fake that look totally real, and you can't tell that they've been faked. We also worry about the human in the loop, which always sounds like a good thing, but sometimes it looks like, say, in battle situations or conflicts, you've got to make decisions at machine speed and not at human speed. And how do we do that in a safe, reliable, and secure way? So we still don't know how to do that. It sounds good, but we haven't gotten there yet. We also have to deal with the issue of military industry, U.S. industry, other industry cooperation on national defense. There's been a lot of issues with civilian resistance to military uses of AI, and these are things that have yet to be worked out. And finally, we have this issue of the AI-savvy workforce. We've heard about how in other countries, especially in China, a lot of people are studying artificial intelligence and learning how to put it to use. And we've been talking about trying to have our own workforce be AI savvy so that we can be smart in the way we use AI. So there's a lot of emphasis being placed on this in this country, and we still don't know how to do it at such a large scale. So these are all issues that we need to find resolutions for. The machines can support what we decide in these areas, but the machines are not going to be able to find the solutions. So these are left to us to resolve these dilemmas. This is my final thing here, just a little statement. I'm not going to read it to you. It's something for you to read on your own. It's part of our backup materials. Just a little last caution here about preserving our humanity in the middle of all this machine stuff, which machines are just simply, they follow lots of rules, but they don't have compassion, they don't have understanding, they don't have empathy, and we can't be a functioning society and a functioning civilization without those. So this is a little exhortation for you to keep all of that in mind as you go out and practice in the AI world. And with that, I declare the end of our course here. It's been a pleasure to talk to you while we do this and deal with all of our speakers, covering all this material. And I hope that it's been useful to you, and you can go and take it out into your world and be a more AI savvy person in the things you do. So thank you very much for being with us.